For generations, Mars has captured our imaginations, beckoning us to explore its mysteries. It's a red beacon in our night sky, a celestial neighbor that has fueled countless dreams of interplanetary travel. Mars is promising new frontiers, holding the potential for scientific discovery and perhaps even a future home for humanity. But the journey itself has always been the most significant barrier, a daunting obstacle standing between us and the red planet. It's a grueling 6 to 9 month trek through the unforgiving expanse of space, a prolonged voyage that pushes the limits of human endurance. This extended travel time exposes astronauts to dangerous levels of cosmic radiation, posing a serious threat to their long-term health. Furthermore, prolonged exposure to microgravity leads to a cascade of physiological challenges. The longer the trip, the greater the risks to the crew's well-being, making mission planning a complex and delicate balancing act. We're talking about bone loss, muscle atrophy, and a weakened cardiovascular system. These are just some of the long-term health complications that astronauts face on such extended missions. But what if we could dramatically cut the journey time, shrinking it to a mere 3 months? A new approach, a bold reimagining of interplanetary travel, grounded in today's cutting-edge technology and innovative engineering, could make this ambitious goal a tangible reality, bringing Mars within our grasp. By rethinking our route to Mars and embracing these advancements, we may finally bring the long-held dream of human exploration of the red planet within reach, opening up a new chapter in space exploration. At the University of California, Santa Barbara, a groundbreaking discovery has been made. Physicist Jack Kingdon, a leading expert in orbital mechanics, has meticulously mapped a faster path to Mars, potentially revolutionizing our approach to interplanetary travel. And the key to this accelerated journey? It's not about developing entirely new, more powerful rockets, but rather about employing smarter, more efficient trajectories through space. Using advanced algorithms, sophisticated computer modeling, and harnessing the potential of SpaceX's Starship, a next-generation spacecraft designed for deep space missions, he's identified specific launch windows, optimal times for departure that could slash the total travel time to the red planet, making Mars missions far more feasible, down to a remarkable 90 days. This is achieved by cleverly leveraging planetary alignments, taking advantage of the gravitational forces of celestial bodies to slingshot the spacecraft along its path, and relying on existing chemical propulsion systems, the tried-and-true technology that has powered space exploration for decades. This plan isn't just theoretically possible, it's both practical and realistically achievable within the next decade, bringing the dream of human missions to Mars closer than ever before. Specific mission windows in 2033 and 2035 could potentially see astronaut crews making the round trip to Mars and back in just a few months each way, significantly reducing the overall mission duration. This isn't science fiction. This is a tangible plan. It's a calculated and deliberate use of orbital mechanics to not only minimize the inherent risks of space travel, but also to maximize the health and well-being of the astronauts on board. Arriving at Mars faster means crews are healthier, both physically and mentally, and more alert, and therefore, they're ready to work and conduct vital research the moment they land on the Martian surface. The secret? In-orbit refueling and making fuel on Mars. Starship launches into Earth orbit, then is topped off by a fleet of tanker ships. Fully fueled, it accelerates on a fast trajectory to Mars. Once there, astronauts use Martian resources, CO2 and water ice, to produce fuel for the return trip. This approach, called in situ resource utilization, turns Mars into a refueling station. The result, a lighter, more efficient mission with a clear plan for both arrival and return. It's a smart use of existing tech, making a 90-day Mars sprint possible. The ambitious plan to reach Mars in just 90 days isn't without significant hurdles. It presents a series of complex challenges that must be overcome to ensure mission success and the safety of the crew. Dozens of launches are needed to refuel Starship in orbit, a critical step to amass the necessary propellant for the long journey to Mars. This requires precision and coordination on an unprecedented scale. This propellant aggregation in space is demanding a rapid, reliable launch cadence, pushing the limits of current launch capabilities and infrastructure. We need to launch, refuel, and prepare for the journey in a streamlined fashion. High-speed arrivals back on Earth means Starship's heat shield, a crucial component, must withstand extreme re-entry temperatures, enduring intense friction and pressure as it plunges through the atmosphere. These are tough engineering challenges, requiring innovative solutions and cutting-edge materials to ensure the spacecraft's integrity. But these challenges are not impossible ones. History has shown that human ingenuity can overcome seemingly insurmountable obstacles. The rewards, healthier crews, benefiting from reduced exposure to cosmic radiation during the shorter journey, safer missions, minimizing the risks associated with long-duration space travel, and a sustainable path to Mars, a stepping stone to establishing a permanent presence on another planet, make them worth solving. The potential benefits far outweigh the difficulties. Kingdon's concept has energized the space community, sparking renewed interest and collaboration among scientists and engineers. It is offering a real roadmap for the 2030s, providing a tangible goal to strive towards in the coming decade. A 90-day journey could transform Mars, drastically altering our perception of interplanetary travel. It would shift Mars from a distant dream to a reachable world, inspiring future generations to pursue careers in science and exploration. The highway to Mars is opening, paving the way for unprecedented scientific discoveries and human expansion. It is inviting a new era of exploration and discovery, promising to reshape our understanding of the universe and our place within it.